Everyone, welcome to this course. This is Yplex Neural Network Design by a high schooler, namely me. Today is day one, Deep Learning Intuitions. But before we get there, let's cover a little bit about what this course really does and some things you might want to know and tips. So a little bit about me. I'm a fellow high schooler like most of you, and I started coding machine learning models like a year before. So it hasn't been that much time. Something I realized that a lot of neural network courses that are meant to help people know aren't exactly friendly to beginners. For example, they require access and prior knowledge in things like linear algebra, matrix operations, and statistical modeling methods like z-tests and p-tests. Obviously, if you're a high schooler, there's a high chance you don't know what those are, or if you don't have a high level of education, it might be very difficult to understand. So, we are developing the Yplex Neural Network course specifically for the biggest and lowest level of beginners to take them up and teach them all the aspects of neural networks. With a little bit of that, let's get started. For this course, you're going to require a coding platform, obviously, because that's what machine learning is. So I recommend using Google Collaboratory, and it's accessible via Jupyter Notebooks or vice versa. Using any one of them works. Just any coding platform where you can use TensorFlow, Keras, even Kaggle works for this. I recommend you take notes on Google Docs, and if you're feeling lazy, you can just take images of this course while you're feeling lazy. Some helpful prior knowledge, so I do recommend that you should know a bit of calculus. I recommend you know the basic idea of what a derivative is because this is useful for back propagation. I recommend the basic idea of summation and integrals as well because this is useful for understanding cost functions as we get deeper into the ideas. And finally, I recommend you learn basic ideas of limits to learn activation functions. If you don't know half the words I just said, then just remember, just know what a derivative is, integrals, and limits. Just the three basic parts of calculus. We'll cover a bit of what we do in this course. So the first thing we'll do is cover all the deep learning fundamentals and understand how to build a very, very basic neural network. We'll cover things like what gradients are, forward and backwards propagation, cost functions, loss functions, optimizers, and all of that. Then, we'll actually get into hands-on coding by building neural networks from scratch, that is, without any libraries like TensorFlow or PyTorch. Then, we'll conduct 1 to 2 special feed-forward neural network projects, so you can add them to your own resume or list of projects. Then, we'll go to hyperparameters, understanding what they are and how they impact models. And then finally, we'll learn about CNNs and RNNs before concluding with special projects on both of these. Welcome to the Yplex course. Day 1, Deep Learning Intuitions. Suppose that I wanted to model the price of a house based on the size. I had an input x, and that would be the size, and I wanted to compute the price of the house, y. So, I had 6 examples, and I plotted them on this graph here. The size of a house on the x-axis and the price on the y-axis. If I plotted them together, it's clear to see that it's a linear relationship. And since the price can never be negative, we know that there will always be a minimum price of $0.00. So we can just put a 0 here and then draw a linear relationship here. And this is essentially what a neural network is. You take an input, or size x, you use a neuron, which is basically just a mathematical operation performed on the input data to get an output y. This is the most basic type of neural network, and the large neural networks that seem to have multiple layers are just stacking these neurons together with lots of inputs, lots of neurons in the middle, and lots of outputs. Let's see what this really looks like. Assume that size isn't the only thing that plays a role in how much a house costs. For example, size is one factor, but the number of bedrooms is also another factor. These two factors determine if a family of 3 or a family of 4 can actually live in that house and afford it. So, that's one factor that can be used to make this neuron. Also assume zip codes and wealth. These two dictate first the walkability and second the school quality that it has. And so, if you live in a better school district, you're more likely to pay money to go to a better district, which again raises the prices. Ultimately, we can have multiple inputs like this that ultimately result in a neural network that is much larger than the neural network previously. Take this neural network, stack it together, and this is how you arrive at what we see as deep neural networks, where we have an input layer, a hidden layer, and an output layer that ultimately gives us the price. Each of these tiny neurons conducts this function right here and computes it. And in neural network vocabulary and modern architecture, this is known as the ReLU function, or rectified linear unit. It's just one type of activation function out of multiple that you can use with neurons themselves. So a bit more about what neural networks actually are. They are machine learning algorithms that use supervised learning. And what supervised learning is that it's given an input and an output, and a model is trained to predict the output, whether that's classification or regression. For example, home features, for example, the size of a house, the number of bedrooms, the zip code, and the wealth, are all dictate the price of a house. So our input is X, those features, and our output is Y. And each of these are examples of what and how neural networks can positively impact a lot of these businesses. Today, neural networks are used in real estate, online advertising, photo tagging, speech recognition, machine translation, and autonomous driving. It's crazy to think about, but neural networks are truly the state of art of what's happening in the future. So one of the most important aspects of understanding what neural networks are is understanding structured versus unstructured data. Structured data is arranged properly. It's within rows and it has columns. It's like a matrix, or it's like a graph or chart that has all the important information. Unstructured data is probably what you've heard about. A neural network diagnosing cancer, or a neural network identifying whether an image is a cat or a dog. These types of data aren't properly structured. They're image data, audio data, and textual data. And these are what neural networks have learned to evolve to. Ultimately, this just means that neural networks have much more application within both of these fields, and where they excel over traditional methods is entering unstructured data for future involvement. So there's several types of neural networks. It's not just one or two types. In fact, there's thousands of different architectures, but the three main ones are, number one, an artificial neural network. That's the neural network that was right here. You take an input, it's a hidden unit, and then you compute the output with a function. Then you have convolutional neural networks. These use convolutions, or small filters, step by step to ultimately diagnose and see patterns within an image, and they're used for image data. And finally, RNNs, which are sequential models that take sequential data like text, and then try to predict the next text or more. Neural networks are rapidly evolving, and so in the next video, we will cover how neural networks really work by going to depth on backward, forward, and many other types of propagation.